Hello everyone, Amod here from the Target Common YouTube channel, and I am here with another array based Java program. So in this video we are going to learn bubble sort. Okay, this is again if frequently asked interview question, and this is really simple, just need to think. Okay, so I am not going to start with the definition or something. Okay, I'm just going to sort one array. Okay, and later we'll name it what it is called. Okay, so for an example, here we have one array, and we have 5 elements here like 12, 7, 9, 3 and 1. Okay, and my what I want, that I want to sort it in ascending order. What is meaning by ascending order? Means the smallest number should come first, then it should be ascending, right? It should be like first it should come 1, okay, there should be 3, then 7, then 9, then 12. Okay, smallest to bigger. That is the sorting we want to do, and this is the output we are expecting. Correct? So just think that you are not a programmer, you are simple a student or like a school going guy, and you just want to sort this array. Okay, by not using any programming language, just by the logic. Okay, so we have 5 elements here, but leave about the last 3 elements. Just think about the first and second element. Okay, if I ask you whether these elements are sorted in ascending order or not, okay, then what will be answer? Okay, 12 and 7, obviously it is not in order, because we expect in ascending order, so that means 7 should come first, right, then 12, right? Simply we are checking only on these two numbers, we are not checking for others, we are not bothering about the others, we are just considering about the first two. Okay, and what we decided from this, okay, these are not in proper order, 7 should come first, right? So what I will do, I will put 7, then 12, okay, and let it put everything as it is. Okay, 9, then 3, then 1. Okay, so just looking at the first two numbers, we have sorted in this way, and 7 is coming first before 12. Okay, now we have already decided for the first two. Now decide for the this one and this one. This means second and third. Okay, means what we are doing here, we are just checking that whatever element we have currently, if that element is at correct position compared to the adjacent element. Okay, if you see here 12, at the second position we have 12, and third position we have 9. Okay, so do you think that it is sorted in ascending order? No, because 12 is greater than 9, so obviously 9 should come before 12. Okay, so again again we will have another pass, and it will be like 7, and instead of 12 what will come? 9, and we are swapping actually. Okay, we swapped here because 12 is greater than 9. Okay, so 9 will come first, then 12. Okay, and let it be 3 and 1 as it is. Okay, now compare the third and fourth one. You can see how we are comparing 1 and 2, then 2 and 3, then 3 and 4, then 4 and 5. Okay, so what are numbers are in question? 12 and 3. Are these numbers sorted in ascending order? No, because 12 is greater than 3. Then 3 should come first, not 12. Okay, so again we need to swap. So what I'll do, so it will be as it is 7. Okay, means we need to swap only those two numbers which are in question. We are not bothering about the other remaining numbers. Okay, It will be 9 as it is. Then instead of 12, what we need to put? 3. Okay, and instead of 3 we will have 12. Okay, and 1 will be as it is. Okay, now the fourth one and fifth one. So since we are considering only fourth and fifth one, so we are not bothering about the other elements. So are 12 and 1 sorted? No, because 12 is greater than 1, and obviously 1 should come first here because we are sorting in ascending order. Okay, so what we need to do, instead of 12, it should be 1. Okay, and it should be 12. Okay, and remaining every element will be same as it is. Okay, so sorry, so it will be 9 and it will be 3. So logic is simple here. What we are doing, we are just comparing two adjacent elements starting from the first position. Okay, so this is the first, this is second. So compare first and second and sort or swap if they are not in ascending order. So we got to know like 12 is greater than 7, so we need to swap them. Okay, so what I did, we swap them. Okay, then what is the next number, and other numbers will be in the same position. Okay, then in the second iteration we need to consider second and third element. Similarly third and fourth, and fourth and fifth. So we need to compare the adjacent elements and we just need to ignore the other elements. Okay, so I hope this pass is clear to you, and at end of this pass we see still elements are not sorted, right? So let's go and do the same thing again whatever we did here. So see here, again question, we need to start from the first, right? So 7 and 9. So are 7 and 9 sorted? Yes, 7 and 9 are sorted, right? So what I'll do, I will do 7, okay, and 9 will be in same order, right? And since we are considering only first and second, so other elements will be as it is, so we are not bothering about that one. So I will put it as it is. Okay, 1, and it will be 12. Okay, then what are the next comparison here? We need to compare the second and third, right? 9 and 3. Are these elements sorted? No, right? Because 9 is greater than 3, and due to ascending order 3 should come before 9. So here we need to do a swapping, right? So what I'll do, 7 will be as it is because we are not considering it now, and it will be 3, right? We are swapping here. Okay, and it will be 9, and here will as it is means 1 and 12. Okay, 1 and 12. Okay, now third and fourth, you can see for each pass we are simply incrementing first, second, second, third, third, fourth, and fourth and fifth. So here we have to compare what, 9 and 1. Are they sorted? No, because 9 is greater than 1, so 1 should come before 9. So what will happen this time? Instead of 9 we will have 1. Okay, and instead of 1 we will have 9. Okay, and remaining elements will be as it is. So what I will put, 7. Okay, then it will be 3, and it will be 12. What is the last check here? 4 and 5th. So are 9 and 12 are in order? Yes, they are in order because 9 is smaller than 12 and 9 is coming before 12 here. So at this stage there will be no swapping and we will get the same numbers, same sequence as it is. We have 7, 3 and 1, then 9, then 12. Let's see the output. Okay, let's see the output. Still the final array is not sorted, right? We can see we should expect 1 3 7 9 12, but we are getting 7 3 1 9 12. We are not sorted, right? Let's go and do the same logic again. So first element, second element. Are 7 and 3 in order? No, because 7 is greater than 3. So obviously 3 should come before 7. So what I need to do? So do a swap. So 3 and 7. Okay. And the other elements will be as it is, like 1, 1, then 9, then 12. Okay. Okay. Now we need to compare second and third element, right? So 7 and 1, are they sorted? No, because 7 is greater than 1. So 1 should come before 7. So instead of 7, what we will have? We will have 1. And instead of 1, what we will have? 7. Okay. And it will be like 3 and 9 and 12. Okay. Same thing here. Now, what is the thing? We have to compare third and fourth. Are 7 and 9 sorted? Yes, because 7 is smaller than 9 and it should come before 9, which is coming. Okay. So, again in this pass we will have the same thing, like 3, there is no swapping, nothing changed. So 7, 1, then 7, then 9, and then 12. Okay. Now this element and this means fourth and fifth. So again there will be are, because 9 and 12 are in same like in order, so there will be no swapping, right? So we'll get the same as it is, like 3, 1, 7, then 9, then 12. Okay. Let's see the output of this array. Still the elements are not sorted, right? Still the elements are not sorted. Let's do the same thing again. Okay. So this time we are comparing 3 and 1. Okay. So are 3 and 1 sorted? No, because 3 is greater than 1. So obviously 1 should come before 3. Okay. So in this situation what we need to do? Instead of 3 we need to put 1, and here it will be 3. It will be 3 here, right? Because we need to swap here, and remaining elements will be as it is, like 7, 9, and 12, right? What we need to question again? Second element and third element, because once we are starting the process, so we need to go, right? Second element and third element, are they all sorted? Yes, 3 is smaller than 7 and it is coming before that only. So in the second pass we will have the same numbers in the same order, like 3, then here it will be 7, then here it will be 9, and here it will be 12. Okay. Now third element and fourth element, are they sorted? Yes, 7 is smaller than 9. Okay. So again we will have the same representation, like 1, then 3, then 7, then 9, then 12. Okay. Now for the last two elements, 4 and 5th, are they sorted? Yes, they are sorted. So there will be no swapping and we will have the same number whatever we have in the previous order. So 1, 3, then 7, then 9, then 12. Now see the output. Okay, we see like it's now sorted 1 3 7 9 12. Finally we got it. Okay, So we did the four passes, and finally we are done with the sorting, and we got what in the ascending order. Okay, so logic was very simple. We need to compare the adjacent elements starting from the first position. Okay, like first and second, second and third, third and fourth, and fourth and fifth. And you need to compare if the first position element is greater than second element. If yes, then swap it, because we are sorting in ascending order. But if you are doing the descending order, then you need to change the condition. Okay, but the logic will be same. You need to compare the adjacent element. Okay, you need to start from the first position, then first, second, second, third, third, fourth, and fourth, fifth. Okay, and you need to do the same comparison, same logic till your array is sorted. Okay, we can see that in the four passes we have sorted the array. Okay, so this is the logic, right? So it's not very hard, very difficult. It's like very simple thing here. Just need to compare the two adjacent element till you get the sorted array. Now let's think as a programmer now. Okay, so this array contains how many elements? Total 5 elements. Okay, and if you see here, how many passes we required? 1, 2, then 3, then 4. So what we can conclude here, if we have 5 elements, then we require number of passes n minus 1, where n is the length of the array. Okay, so what is the first point we can conclude here? Number of passes. Okay, it will be length minus 1. It is making sense, right? We can see here, like total we have 5 elements. What is the length of this array? 5. And how many passes we require to sort this array? 4. So we can conclude that we require the array of length minus 1 passes. Okay, and how many times we need to compare? If we have 5 elements, so how many times we compare? First and second, one comparison, second and third, third and fourth, and fourth and fifth. Okay, so what we did, how many comparison? Okay, how many comparison? We did 1, 2. Okay, then we did 2, 3, then 3, 4, and 4, 5. So how many total we did? Total 4. Okay, so means if we have 6 elements, then total count of total comparison will be 5. We have total 5 elements, so how many comparison we did? 4. Okay, so we got the second logic, right? So how many passes we required? Length of array minus 1. How many comparison we required for each pass? For each pass actually 4. That is will be again array length minus 1. Okay guys, so let's see one important point here. After first pass we see 12 at the last. After second pass we see 12 is constant and we have 9 here. Okay, in the third pass, after third pass we see 9 and 12 are constant and we see 7. And in the fourth pass, which is the final pass, after that the array is sorted and we see like the 3 elements were constant. Okay, so actually in sort, what is happening, after each pass we'll get one sorted element. Okay, means for the after the first pass, last element will be sorted. Okay, after second pass, 2 elements will be sorted at the last. After the third pass, 3 elements will be sorted at the last, and after the fourth pass, 4 elements will be sorted at the last. Okay, In after every pass, if we are getting the last element sorted, okay, or one element at the correct position, okay, then how many actual number of combinations we required for the first pass? Okay, obviously we require 4, correct? We require 4, 1 2 2 3 3 4 and 4 5. We know that after the first pass, last element is sorted here, okay. So do you think do we really need to compare with this? No. So what we need to do? We need to compare with the 1 2, then 2 3, and 3 and 4. We require only 3 comparison, okay, because there no need to compare with the 1 and 12, because we know that 12 are already sorted, and after end of this pass 9 and 12 will be sorted, are at the correct position, okay. So in the third pass, do you think that we need to consider 9 and 12 again? No, right? Because these are already sorted. How many combinations we require now? 1 and 2, 2 and 3, okay, 2 and 3. So how many combinations required? Only 2, okay. And same thing here, how many combinations we required? Because after end of this third pass, 7 9 and 12 are sorted, so we have only two numbers in question, 1 and 3, so just need to sort it during the one comparison, right? So did you get the logic here? How many number of passes you required? Total number of elements in the array, or the array length minus 1. How many comparison we require? Okay, so this is actually tricky here. If you see as a layman term, so we have compared compare every time, right? Means we did 4 comparison in each pass, right? But as we got to know, like after each pass we will have one sorted element, okay. So for the first pass only we need to do the 4 times of comparison here, okay. And here from the next pass we need to do minus 1. Here 4 number comparison, here 3, here 2, here 1. So how many comparison we did here? We did only 4, okay. Okay, how many we did here? We did only sorry okay. So here how many we did? Only 3, okay. How many here we did? Only 2, okay. Here will only 2, okay. And how many here we need to do? Only 1, okay, only 1. So can you see, can you get the logic now? Did you understand the how this sorting is working? The logic is very simple. After doing the iteration, after doing the all the passes, we are just driving we are just extracting the logic, okay. What are the first logic? Number of passes, because obviously we need to use 2 for loops here, okay. One will hold the this one, how many passes we required, okay. And second will hold how many comparison we required, okay. So let's go to Eclipse now to write the logic. Already created one class called bubble sort here, and I've created the main method. Let me do int array, okay, and I will have the same elements. So what elements we have? 12 7 9, 12 7 9, then 3 comma 1, like same array. So we know that we need to use 2 for loop. One first for loop will be responsible for the number of passes. So how many passes required? N minus 1, where n is the length. What I need to do? Int I equal to 1, I less than array dot length minus 1 I plus plus, okay. And since we are using array, and we know that in array index starts from 0, okay. So whenever you are writing any program based on array, so always start from 0 instead of 1, Okay, that will really make the life easier. Okay, otherwise you need to do -1 and +1, so don't do that one. Simply start from 0. Okay, 0 and this one. Let's debug this one. So if you start from 0, okay, and we're putting array dot length, so what will the output of this? 5. 5 minus 1, okay, 4. So how many iterations it will go? 0, 1, 2 and 3. Okay, actually when I started from 1, so that time it should not be -1 actually, but yeah, since I am putting I equal to 0 and I need to go for n minus 1, where n is the length, right? So means 4 iteration. So here array dot length will give me 5 minus 1, 4. So 0, 1, 2 and 3. So 4 iteration it will go. Simple. Now second iteration. Second iteration will keep the counter on how many comparison we required. Okay, so let's start from int I int j equal to again from 0 itself. Okay, and how many comparison? So first thing we need to do array dot length minus 1. Okay, j plus plus. One second. Okay, if you just leave about this last element sorted logic, so how many combination we required? 4, right? Which is similar to the number of passes. Okay, so we can have the same logic, right? Because both and I and j both should go till 4 only, right? Or that is array dot length minus 1. Okay, so here it is same. But when I want to implement that, the last element will be sorted after each pass, right? Actually, I'm using the term last element, but it will not be the last, but you see one element sorted after every pass. So for the first pass, we need to go for total 4. Here for the second pass, we need to go for 3. For the third pass, we need to go for 2, and for the fourth one, we need to go for 1. So you can see, as the number of passes are getting increasing, your number of compas is getting decreasing. Okay, number of passes increasing, number of compas decreasing, right? The logic. See, I am trying to find a relation between number of passes and number of comparison here. Passes increases, comparison decreases, right? By the same. Passes by 1, passes is increased by 1, comparison will be decreased by 1. So can I do array dot length minus 1 minus I? Right? I found the connection between I and j here. Okay, and that I implemented the logic. Okay, now we need to come to the another logic where we need to swap the values. Okay, means if the first element is greater than second element, then we need to swap, right? We have done already here, right? Because 12 is greater than 7, then we need to swap them, 7 and 12. Okay, so how to do swapping? Here we'll use the a temporary variable which you can use to swap. Okay, so suppose we have a container A, okay, and we have container B. Okay, what I want to do, I want to put the content of B into A and content of A into B. Okay, we are interchanging. So what I need to do, I need to use another container C. Okay, what I will do, I will put the content of container A into container C. Okay, okay, and now container A is empty. What I will do, I will put the container B contained into container A now. Okay, and in the container B is now empty, so what I will put the content of container C into container B. It's simple. It's simply swapping using the third variable. Okay, so what I need to do, I need to put a condition if array of j, okay, is greater than array of j plus 1. Why this logic? We have to compare the first and second. Okay, and all the time j will hold the pointer in the array, right? First element, second element, third element, fourth element. So we are taking the currently pointed element if it is greater than the next element. Okay, that's what we are doing. First, second, second, third. Third is the next element of second, right? If the this element is greater than the next element, okay, then we have to swap. So what I need to do? And to use a time variable in time equal to, okay, inside this what I'll do, I'll put the content of j, means the first element. Then in the first position, okay, I'll put the content of j plus 1, right? Okay, and then in the j plus 1, okay, I'll put the time. Okay, same logic whatever I explained for the containers here, right? So that's all we required here. Now let me print it. I'll use the traditional for loop, int k equal to 0, k less than array dot length, then k plus plus. Let me print the all the numbers, array of k. So let me run and let's see if it sorts the array or not. Okay, so 1, 3, 7, 9, 12. Wow, great, we are able to sort it. Okay, let me change some numbers, like let me put it -3. Okay, and see. So -3, 1, 7, 9, 12. Oh, correct, it's happening, right? So our logic is working fine. Okay, let's think more. If you see all this logic here, okay, so here I have taken one example where in each pass we have the swapping happened. Okay, purposefully I took some example, but we never know if the elements are already half sorted or something, right? Here elements are not at all sorted, so we did a lot of swapping here. But suppose if the elements are suppose elements are like this only, you got the element like this 3, 1, 7, 9, 12. Okay, in this element already 7, 9 and 12 are sorted. Okay, you just need to sort this once, right? Only for this. So do you need to compare all these many passes? No. So means in simple logic, suppose if there's no swap, there's no swapping happened in a pass, during a pass. Okay, suppose this is the first pass and nothing, no swapping happened. Suppose it is already sorted. Just consider this one only. 1 and 3, no swapping. 3 and 7, no swapping. 7 and 9, no swapping. 9 and 12, no swapping. Okay, so we are done with the first pass and there no swapping happened. Do we think that we should go for another remaining passes? No. So if there's no swapping happened in a pass, then we can terminate our for loop or terminate our process, because we know that elements are sorted. Okay, we have seen the example here as well. So what I am going to do here, I am going to have one like boolean. I'll put is sorted. Okay, and by default I will put it false. Okay, if during the comparison, if we are going inside this block, then what I'll do, I'll put is sorted as I'll put it as true. Okay, and here I will put mark it false. Okay, so what I am doing here, if any swapping is happening, okay, that means array is not sorted, we need to go for remaining passes. Okay, then I am making no, it's not the sorted element. Okay, so it will become false. So after this loop, okay, after this loop we have to check if is sorted is still true. If yes, then you need to break. Okay, you need to break because elements are already sorted. There is no need to go for the further passes. Okay, so let me run this program and we see the proper output, right? So by implementing this logic, we are making our program optimal, little optimal. But yeah, this is not the like optimal solution completely, because we have other sorting algorithm as well. But yeah, in the in this sorting we can implement this type of logic. Okay, and actually whatever we have done, this is called bubble sort. Okay, this is called bubble sort because after each pass we are getting one element sorted, right? So like bubble kind of things. So that's why the name is bubble sort, and this is the logic. Okay, and this is really simple, just to think more. Okay, so if you have any confusion, please comment on this video, and if you want me to cover any specific program, so that also you can comment on my video, or you can send out a mail to me. And if you are liking my video, please like, comment, subscribe and share with others. Thank you everyone.